This is Chapter 7, Section 4, Applying Properties of Similar Triangles. Your objectives for this lesson are to use properties of similar triangles to find segment lengths, and to apply proportionality and triangle angle bisector theorems. Your first theorem is the triangle proportionality theorem. This theorem says that if the line that is essentially a transversal through your triangle is parallel to the opposite side, then you're able to make two ratios into a proportion. So AE to EB is equal to AF to FC. Here's our first example. Our directions are asking us to find US, which is this segment here. It's given that U, V, and ST are parallel. Because they're parallel, we're allowed to use the triangle proportionality theorem. So we need to start by setting up a proportion, which is that US to RU is going to be equal to VT over RV. After we set up our proportion, we need to substitute the values into the proportion. So we know that RU is 14. We know that VT is 4. We know that RV is 10. And US is the one that we're looking for. So we got all of those values for my diagram there. Now we need to use cross products to solve. So I'm going to multiply at a diagonal. US times 10 gives me 10. US 4 times 14 is going to give me 56. Divide both sides by 10, so I'm using the division property of equality. And I get US is equal to 56 over 10, or if you want to change that to a mixed number, it will be 5 3/5. Both of these answers are acceptable. If you would like to practice this on your own to make sure that you understand, you can go to page 484, work on number 1, and you can check your answer in the back of your book. Here's your next theorem. It's the converse of the triangle proportionality theorem. So this one says that if I can create two ratios and the ratios end up being proportional, then I can conclude that this line and this segment here are parallel. So here's our example for that problem, or for that theorem. We need to verify that DE and BC are parallel. So DE and BC here, we need to make sure that those are parallel. And we're going to start by setting up our ratio. So I have 10 over 15, or 10 to 15, and then we also have 8 and 12. 10 to 15 and 8 to 12. If these reduce to the same ratio, which means both sides are proportional, then we are going to have two segments that are parallel. So 10/15 reduces to 2/3, and 8/12 reduces to 2/3. They are equal, so that means that these two segments are parallel. And this is using the converse of the triangle proportionality theorem, which says if these two legs are, their ratios are proportional, then those two segments are going to be parallel. So our next theorem, or corollary, it says that if I have 3 or more parallel lines intersected by two transversals, then these segments here are going to be proportional. So I have AC to CE is going to be proportional, or the ratio is going to be equal to BD to DF. Here's our third example. So we're going to be using the transversal proportionality, which we just learned. It says in figure in this figure here, if AB is 4.5 and it's already labeled, this segment here, BC 2.6, again it's already labeled, CD is 4.1, and then KL is 4.9. You need to find LM and MN, so these two segments left here, to the nearest tenth of an inch. Because it's given that all four of these lines are parallel, we're allowed to use the two transversal proportionality theorem, and so we can set up, or corollary, excuse me, we can set up our proportions. So I have KL, which is 4.9, is going to, let me write that down. I have KL, and then MN, which is one of the ones that I'm looking for, equal to AB over CD. So KL, MN, AB, and CD. These two are directly across from each other. And then I can substitute the values in. So I get 4.9 over MN is equal to 4.5 over 4.1. Use cross products to solve that. 4.9 times 4.1. And then on the other side I have MN times 4.5. And I am running out of room. But if I divide both sides by 4.5, I'm going to end up getting MN being equal to 4.5 inches. That's only part of my answer, so now I'm going to have to solve the other missing section. Again, I'm going to start with KL and LM now, since that's the missing one that I'm still looking for. KL over LM is going to be equal to AB over BC. AB over BC. So again, segments that are directly across from each other. So same as the other one, I'm going to substitute my values in. I get 4.9 over LM, which is the segment that I'm looking for, equal to 4.5 over 2.6. Using cross products and multiplying, that gives me LM times 4.5 equals 4.9 times 2.6. Excuse me. And I'm going to end up getting LM equal to 2.8. And those were the two segments that I'm looking for. Again, extra practice can be found on page 484, number 5. And you can check your answer in the back of your textbook. Last theorem, triangle angle bisector theorem, says that if I have a triangle with one of the angles bisected, so these two angles are congruent, then I can say that BD over DC is equal to AB over AC. So the smaller, well, it doesn't really matter what's just smaller, but one side of the base to the other, and then the leg over the other leg. Excuse me. So example 4, we need to find PS and SR. It's given that this angle here is being bisected, so we can set up a proportion by using the triangle angle bisector theorem, which is the one that we just talked about. So I can say that PS over SR is equal to QP over QR. So these two base sides and then the two legs. PS over SR is equal to QP over QR. And then I'm going to substitute my values that are already marked on my triangle. Gives me x minus 2 over x plus 5 equal to 32 over 40. Again, we're using cross products. So I have 40 times x minus 2 equal to 32 times x plus 5. I'm going to distribute. Gives me, 40x minus 80, 2 times 40, equals 32x plus 32 times 5, 160. Then I'm going to use the addition property of equality and the subtraction property of equality to solve. I'm going to minus 32x from both sides. And I'm going to add 80 to both sides. Those are my zero pairs. I end up getting 8x equal to 240. Divide both sides by 8, I get x equal to 30. But the question didn't ask me to find x, it asked me to find PS and SR. So I need to substitute it into those values. PS is x minus 2, which is 30 minus 2, which gives me 28. And then SR is equal to x plus 5, which gives me 30, plus 5, which gives me 35. And again, for extra practice, there's a problem similar to this on page 485, problem number 7. It's an odd number, so you can look it up at the back of your book to make sure you got it right. So if you want to know whether or not you've gotten everything out of this lesson that you were supposed to, you should be able to answer the following 4 questions. What does triangle proportionality theorem say? What does the converse of the triangle proportionality theorem say? What does the two transversal proportionality theorem say? And what does the triangle angle bisector theorem say? This is the information that I'm going to be expecting to see in your summaries. If you have any questions, make sure that you write your questions at the bottom of your notes so we can talk about them during class.